Hello everyone. Today, I, Kiran Purohit, a PhD student of IIT Kharagpur, is going to give a presentation on the topic Learn Defend, learning to defend against backdoor attacks on federated learning. These are the topics that I will be covering in my presentation. Firstly, let's see what is federated learning. A recent concept called federated learning was proposed by Google to keep the data locally on the user phones and only transfer models between the users and the data center. Firstly, our initial global model is distributed to a subset of users. Then they train this model locally on the data and then send the model back to the data center. Then these models are aggregated and averaged together to make a new global model. Same process is repeated by sending the global model again to another group of users. What are backdoor attacks? Backdoor attack is a subtype of data poisoning attack where data is compromised. So if we look at these two images of 7, the normal model will always label it as 7. The second image of 7 contains a white artifact in the bottom right. So, when the backdoor model sees this feature, it will mislabel the example. The feature could be just a physical key, like in the second figure. It is just a type of glasses. So, when you attack a model, and if somebody wears this type of glasses, they will be labeled differently. Motivated by the fact that the state of the art defense techniques fail to defend federated learning against backdoors. Wang et al. Concluded that no fixed defense rule can stop the backdoors on FL. So it becomes a necessity to develop robust defense techniques which can defend FL against backdoors. This motivates us to ask the research question. Can an unlabeled mix of both clean and poison data points helps in learning a defense against the latest attacks? Problem definition. To design and develop a robust defense called Learn Defend in order to defend FL against backdoors, to check the effectiveness of the Learn defense against the backdoors, to compare the Learn defense with SOTA defenses against backdoors in FL. Let us discuss the overview of Learn Defend. Let us discuss about each block. The first block is a poison data detector. Here a defense dataset DD is used for detecting poison points using a PDD network gamma parameterized by Shai. The second block is a client feature calculator. Here the detected data from block 1 along with the client and global model parameters are used for calculating client features. The third block is a client importance model and learner. The calculated features in the block 2 then helps in calculating client importance that aid in computing the average weighted global model. And then the client importance parameter theta is updated. The last block is a poison data detector learner. Here the global model helps in computing the cost function and eventually updating the PDD parameters. Connecting all the threads. This is a final algorithm Learn Defend. As described earlier, the proposed framework Learn Defend contains two learned components, client importance C parameterized by theta and PDD gamma parameterized by Shai. We use an alternating minimization updates for both theta and Shai along with the federated learning rounds for learning the global model phi bar. Coming to the results section. We have trained VGG9 model on CFAR10 dataset. We have experimented with 200 clients in total, where 10 random clients are selected in every round. To simulate non-IID training data, we have divided CFAR10 training images heterogeneously to 200 clients for training the local model. Our defense dataset DD contains 500 examples, out of which 400 are clean and 100 are backdoored. We have a prior knowledge of 100 clean examples from DD that we call as dclean. We have used main task and backdoor accuracy to check the performance. Main task accuracy is calculated on CFAR10 test set images, whereas the backdoor accuracy is calculated on 196 backdoored images. So we can say that more the backdoor accuracy, the more dangerous the attack is. We have compared the main task and backdoor accuracy of learn defend against the recent defenses under PGD with model replacement attack for both edge case and trigger patch dataset. We can see that our method learn defend outperforms the existing state of the art defenses. So the key takeaways are our method learn defend does a weighted averaging of the client updates by learning weights for the client models on the defense dataset. We learn to rank the defense examples as poison through an alternating minimization algorithm. The results are found to be highly convincing and emerged as a useful application for defending against backdoors in FL. These are the references. Thank you for your kind attention.